2.1, rates of change. And limits. So, y'all watched the notes in here the other day, and then, had a few days off of actually doing the calculus part, but an object dropped from rest from the top of a tall building falls y equals 16t
I thought it was going to be like a physics problem.
squared feet in the first t seconds. I'm like cold, so it's like having a hard time like writing.
I get exactly what you mean. Like sometimes when I have to write an essay and my hand's cold, I can't do it.
Like I don't feel like the room is cold. I just think that I'm just cold, yes. Alright, so 2 says to find the average speed during the first 4 seconds of fall. Alright, so we know that y equals 16t squared, and we know that it's 4 seconds. So our formula is f of t plus h minus f of t all over h. So delta y over delta t equals, and this is just going to be what that's equal to, filling it in. So 16 times 4 plus 0, so 4, and that piece is being squared because this formula was it being squared, minus 16 times t is 0 squared over 4. So then, what does that end up giving us? 16 times 16 divided by 4.
Wait, I got this. 16. No. Wait. Wait.
16 times 16 divided by 4.
64.
See, I got the 256 part, and I just didn't get the rest.
So, so we're plugging in the 4.
4 is h.
Okay.
So what's 8? Wait. Oh, so there's no t. It's just...
Right, t is 0. 4 is a continuation. Find the speed of the object at t equals 4 seconds. And then it says confirm algebraically, which I thought was how we were going to do it to begin with, so that's what we're doing. So we've got delta y over delta t equals 16 times 4 plus h, because I don't know what h is, squared, minus 16 times 4 squared over h. So 16 times, what's 4 plus h squared?
16 plus 8h plus h squared.
Yep. Minus Virginia. 16 times 16.
256.
256.
I'm still recovering from the last one.
It's alright.
It was the same thing, so I figured you had it under
Yeah,
control.
I had that in my memory still, lingering.
All right, so then distribute 256 plus 128h plus 16h squared minus 256 divided by h. 256's cancel.
Love that.
What else happens?
We can cancel some H's.
We can cancel some h's. I think y'all are beyond me needing to factor it out first, so I can just do this. And y'all know what that means. So I have 128 plus 16h.
I don't think I ever like factored them out first.
Yeah,
I
I
just
just
canceled them
crossed it out.
because. Yeah.
So then, now I need to take the limit as h approaches 0 of 128 plus 16h. And what would that give me?
128.
128 feet per second. And that's the instantaneous speed at t equals 4 seconds.
We were just talking about how I don't know what instantaneous velocity is. Probably should have spent a little more time studying it.
I didn't spend much time studying it. I kind of just understood it because it made sense. It's velocity at that instant.
I'm a little confused. So, why did we plug in 4 for h in the first one and then like t in the second one?
Because h is the value that we plug in for. This second one, they just told us what t was equal to.
So usually it's h unless they tell you otherwise. And then
They'll tell you like t is equal to whatever if they want you to plug it in for that.
okay. So otherwise t is like usually 0.
More often than not, it's going to look like number 4 though.
Okay.
They don't specify which one it goes in, just plug it into H.
I mean, basically.
Pretty
All right, use the limit as x approaches c of k equal to k and limit as x approaches c of x equal to c and the properties of limits to find the limit. So the limit as x approaches c of x to the 4th minus x cubed plus 1 over x squared plus 9. This sounds scary.
Yeah.
All we do is plug in c for x.
Oh.
So c to the 4th minus c cubed plus 1 over c squared plus 9. And that's your answer.
I like that one. I want more of those.
Thought you might.
Yeah.
I was gonna say, what is C? C is just C.
Is this pretty much doing stuff with like the properties of limits?
Basically, anytime you have the limit as x approaches something, with the exception of if it's like infinity, you just plug in the number. As far as this section goes, there are going to be times where we need to cancel things because otherwise we might end up with a 0 on the bottom. So we always want to see if we can cancel something first. And then we'll go from there as far as solving. But we just plug in whatever number it says it's approaching. And that's it. So
I have a lot of these on the AP exam.
I don't think they had a lot of them directly, but they had to use stuff about limits to solve other things.
You okay?
No. Not very good at limits.
You'll become a pro at them by the end of this all.
I sure hope. This will be my year.
Alright, number 8. The limit as x approaches -4 of x plus 3 raised to the 1,998.
Nice. Isn't that like the year after you were born?
Oh, I was trying to decide if it was that year or I forgot. I was gonna ask
Kenny was
that.
born in that year.
98.
4 days in. So I just plug in -4 for x, so I have -4 plus 3 raised to the 1998 equals -1 raised to the 1998, and what does that equal to? 1.
Yes. Just to make sure, if it was 1997, it'd be -1, right?
Yes.
Okay. Just had to.
Is it me or my husband?
It's real. So you're -1. Sounds good. I'm 1. You're 1.
So, if we took the square
What
root
year?
of AC,
2008?
2006.
2006. Okay, I was about to say 2006, but then my cousin was a 2005 and she graduated 2 years ago. So then I was like, but you just said that you would be a positive. So that would mean it has to be even. So I felt like 06 was too.
Yeah.
But, like-
she might be in early 2005.
She is. She's a March of. That's why I did that. I was like, there's no way they're that old.
But, like you're gonna miss out on voting by 1 day.
Yeah,
R.I.P.
I know. They need my vote.
Yes, we do.
Oh, they do. My mom keeps telling me every time she talks about the election, she's like, Virginia, you need your vote.
Do we really?
I'm the reason. I'm like the deciding one.
Virginia is gonna decide all of the state of Virginia.
They need me. I'm the only one capable of doing it.
Sure.
It's like a power up that I earned with my name.
I'll just put a squared by my answer for you.
Yes. Thank you.
Why? Why did I write X? I wrote the limit as X approaches 2, and I'm like, well, how does this work? There are Y's in there. But no.
The inverse.
Alright, so we directly substitute in the 2, so I get 2 squared plus 5 times 2 plus 6 divided by 2, not squared, plus 2. So that gives me 20 over 4, I think,
Mm-hmm.
which is 5.
These aren't as bad as I thought.
They
I
just
feel
look
like
square.
they'll get worse, but you know.
Was that your hand or was that the pen?
That was my hand.
Just like broke your hand, Virginia. You'd
It
be
was
like
actually-
William.
It was my crooked middle finger. It always gives me trouble.
You're gonna end up like William.
I'm
Alright.
broken now.
These ones say to determine the limit graphically. We're just doing it algebraically.
I think
You can put a function in your calculator and see what's happening at a point. So that's why we're just gonna do them algebraically. The limit as t approaches 2 of t squared minus 3t plus 2 over t squared minus 4.
I just wrote limit as t approaches t. How did I even get into this class?
Now, initial glance, if I plug a 2 in for t on the bottom, what's going to happen?
It's gonna give you 0.
It's going to give me a 0. So I know that I can't have that. Not allowed. So I am going to attempt to factor and see if I can cancel anything first because I don't want to have an undefined limit. So what would the top factor into?
T. Let me do this, Josh. I got it. T minus 2 plus 1. Wait, no, never mind. T minus 2, T minus 1.
And the bottom.
T plus 2, T minus 2.
Now what happens?
The T minus 2 and the T plus 2 cancel. Or, oh, those just can't. The T
Right.
minus 2.
The T minus 2's cancel. So I now have the limit as T approaches 2 of T minus 1 over T plus 2. And technically, just so that y'all are aware, for technicality's sake, you should rewrite the limit as T approaches or whatever it is every single time. I do not get that picky about it. I usually don't rewrite it because I just know, but you just have to remember that ultimately you're taking the limit when you're canceling a bunch of stuff out. Some people just forget about it, which is why they say you should write it all the time. So I plug in 2. 2 minus 1 over 2 plus 2 is 1/4.
Yay.
28. The limit as x approaches 0 of 1 over 2 plus x minus 1 over 2 all over x.
You scared me when you said all over. It's like, what else could
Last year's class didn't like when I said all over either. Anytime I said all over, they would go, oh no.
It's just foreboding.
So, what do we notice about this one?
Over 0.
It's going to be over 0, which is a problem.
Yucky.
So I can't plug in directly, can't use direct substitution, so I need to do something else. What else might I do?
Multiply
Can we
By
throw the X on the
1
top?
over x.
What do you mean?
Wait, wouldn't that give us an X squared on the bottom? I don't know.
Are you saying
Like, keep, change, flip. Yes.
so? Yes, but that's still going to give me a 0 on the bottom.
That's depressing.
So I'm not done if I choose to do it that way. Because I would have 1 over 2 plus x minus 1 over 2x. Oh, wait. Times x. That's just going to be a lot. So I would personally, or well, any other ideas before I tell you what I would do?
Just like take an eraser and get rid of the X entirely.
How about get a common denominator?
Oh, that's brilliant. See, this is
Thank
why
you.
you're the teacher and we're not.
So this would give me 2 minus 2 minus x over 4 plus 2x all over x. The 2 and the negative 2 cancel. So I now would have the limit as x approaches 0 of negative x over 4 plus 2x times 1 over x. Now what? And we know why I multiplied by 1 over x, right? Let me see that.
You can cancel out the x's.
Yep, and that would leave me with then negative 1 over 4 plus 2x. Plug in 0 and I get
-1/4.
negative 1/4. And you don't have to like physically plug in the 0. You can just like. I only really like physically show plugging it in if it's like a weirder number. A weirder number? That's not. I don't think that's a word. A weird number or something that's gonna like be a lot, like where it's plugging in multiple times.
What do you mean weirder? I mean it's 2 words.
Weirder?
Why would you just
I think
say
it's more weird. I don't know.
Well,
I don't know.
Weirder is
I'll have to ask Miss Patton.
Yeah.
I mean
I'm
it's-
unsure.
It's very descriptive of itself, so we should use it.
What about funner?
More funner.
More funner?
Get the redneck coming out.
Yeah, the redneck in me. If I say that's Miss Patton, she'll
More
probably-
funner.
She'll like
More
she'll
funner.
like kill you.
She'll be very disappointed.
Either that or she'll just destroy your grades.
Yeah.
Alright. The limit as x approaches 0 of the sine of 2x over x.
Can we like Alt F4 the X on the bottom?
No.
How about hit the escape button?
Can anything cancel?
Don't.
Can't you like make that? Doesn't sine of 2x equal like something else?
Yes, but nothing that's going to be helpful to me really at this point. Well, okay. Ultimately, yes, I am going to do something with that, but not yet. So,
I just say
leave a little bit of space there because I'm going to go back and write something in a minute, but I'm going to go ahead and roll with what Virginia said for a moment. So, sine of 2x can also be written as 2 sine x, cosine x, and then over x from the bottom. So then I could rewrite this as the sine of x over x times the 2 cosine x.
Wait, so the 2 cosine of X just doesn't go over the X anymore?
It doesn't have to. I just split it up. So now, the other day I gave you something that looked like this. And I told you this was equal to something.
1.
It's equal to 1. So, now what I can do is I can use my properties of limits. And I can say the limit as x approaches 0 of the sine of x over x times the limit as x approaches 0 of 2 cosine of x is equal to 1 times the limit as x approaches 0 of 2 cosine of x. I just plug it in. 2 cosine of 0 is... What's the cosine of 0? 1. Which this means this is 1 times 2, which is 2. This is equal to 2. Now, the reason I said to leave a little space, I'm just going to bring it over here because I didn't leave enough for me. So, negative 1 over x is less than or equal to the sine of 2x over x is less than or equal to 1 over x. If I get rid of all the little x's on the bottom, I end up with negative 1 is less than or equal to sine of 2x. Less than or equal to 1. And that's the sandwich theorem. Sandwich. I can't spell.
How did you spell it?
We won't talk about it.
It's not bad.
I just may have put a couple extra letters in there. Sandwich. Which.
Like the Mormons, that's what they would pronounce
Wheat thins.
Why did it whistle like
it. I know.
To be funny.
My notes aren't very organized. I can't find
We did
That's
them in
alright.
class, so that may have had something to do with it.
Yeah, I was writing pretty quick.
If it makes you feel any better, I'm not very organized either. So no little.
I gotta look for something on my web.
All right.
Maybe just don't look for things then.
Oh, I found it finally. A little
Oh
too late.
darn, she found it.
32.
That's a nice number.
The limit as x approaches 0 of x plus sine of x over x. Any suggestions?
Question: why they're all approaching 0?
Because that's a common limit approaching situation.
Can we dx it?
dx it. What do you mean?
Like factor
I
out.
don't know.
No.
Because I don't have one in the top in both pieces.
Can we?
That's not like inside.
Yeah.
Can we call it x
Ooh,
over x
x
plus
over-
sine of x over x?
Yeah. Or just x plus sine of x over x. Right?
So I would have to have this is like the common denominator.
Right.
So both pieces would have to be written over x.
Right.
Okay.
So like what I said.
Yeah.
So I can split it and say the limit as x approaches 0 of x over x plus the limit as x approaches 0 of the sine of x over x. What is x over x?
0. Oh.
1. So what is the limit as x approaches 0 of 1? 1, yes.
Yes, I got one.
Plus, what's the limit as x approaches 0 of sine of x over x?
1.
1. So this is equal to 2.
2.
Oh,
Again?
it finally came out. Thanks.
Yeah.
Printed that like
I meant
2.5 hours ago.
No.
You were there.
Look at us go.
I think I was.
That was Friday.
All right.
We were taking the test, and then she made the answer key while we were taking the test. It was great.
That
34.
box is not
It's
messing
fine.
my brain up.
The limit
Leave it.
as x approaches 5 of x cubed minus 125 over x minus 5.
We're going so fast.
Now all I know is 125
That's it.
is like 5 cubed, so
That
like
is
it's
true.
X cubed minus 5 cubed or x minus 5. So can
It's
we
just-
go anywhere with
We
that?
could do x minus 5, x minus 5, x minus 5.
That would not be equal to x cubed minus 125. Nice try.
Yeah.
Can we factor out a cubed?
So, same,
Same.
opposite.
Always.
Positive. Came to me. All that was coming to me was like the prayer thing of soap. Scripture, observation.
The limit as x approaches 5 of on top x minus 5, same sign. Then the first term squared, x squared, opposite sign, positive. First term times second term, so 5x. Always positive. Last term squared over x minus 5. Ringing a bell.
A little bit.
Difference of
Sometimes
cubes.
Mm.
Yeah. We just split that up into like,
Well, at least we can get rid of that x minus 5.
yeah.
Correct. That's why I did that.
Bye-bye.
Peace out, Girl Scout.
No, I love that.
So I have the limit as x approaches 5 of x squared plus 5x plus 25. Plug in 5, that's going to be 25 plus 25 plus 25, also known as 75.
I was doing a little joke in my head, like, what if I said 74? And then I wrote 74.
All right. Any questions on this?
This,
Virginia's like everything.
yeah.
Just kidding.
The soap thing didn't quite make it there. Something about it. It just,
This whole thing got washed out.
So
yeah.
this is x cubed minus 5 cubed is really what I started with.
Okay.
So what we do, or well, here, let me do it this way. I'm going to use x and a cubed so it's like more generic. So it's the first term, same sign, second term. Just copy down exactly. Just get rid of the, like, cover up the cubes and copy it down exactly. Then it's the first term piece squared, so x squared. Opposite sign, so in this case positive. The first term times the second term, so ax. And then always positive, the last term squared, so a squared. And if it was, let's say, x cubed plus b cubed, then it would be x plus b, so copy down exactly. Then x squared, opposite sign, minus first term times second term, so b times x, always positive, plus b squared. So same, opposite, always positive.
So the opposite goes over the, okay, so we do the signs there. Put those over the signs.
Yes.
Same, opposite,
Always
AP in our
positive.
class.
Yes.
She wrote the 2 letters.
I started writing as like a math problem. I did homework too. Instead of the point, I did a little like multiply dot, and I did equals.
So you're just getting rid of it?
I can't handle that.
Just
Hold on.
deal with it.
Oh, wait.
What was up?
You can't do 43, 45, and 47 yet. We'll talk about those tomorrow to start with. I'm going to let y'all work on those other ones, and then we'll do those to start with. And we may go ahead and start 2.2 tomorrow. Because it's just limits at infinity. So, but I'll give you time to like finish this stuff up so you don't have to do this for homework. We'll go through probably like 44 and like 46 or something, and then I'll let y'all do 43, 45, and 47. So you'll have to hold on those till we go over that. I always forget. I don't have those like written down in my examples because you have to look at the book to do them. So, but you need to also be able to like look at the graph. So we'll just hold and do that.